quick word on this limit that I want to mention to you guys. It looks like a lot more complicated than anything else we've dealt with limits so far, obviously. But I want to point something out, and that is like anytime you have to do limits, the first plan of attack is always plug in the number. Plug in the number that the value is approaching. So in this case, I just wanted to say like h is approaching 0. Really, my first plan of attack could be to plug in 0 to this. Now, if I plug in h equals 0 to this, what's going to happen? I'm going to have g of 1 plus 0. G of 1 plus 0 is g of 1. So I will have a g of 1 minus a g of 1. And I don't necessarily need to even evaluate that to know that these things are going to cancel each other out and make 0. So if I started by plugging in 0, this would end up being 0 over 0. And I wanted to show you guys that briefly because I wanted to remind you that like anytime we're doing limits, first plan of attack, plug in the number you're approaching, and if you get 0 over 0, there's more work to do. And in this, so we don't usually start off by having you guys plug in h to 0 because this is going to happen every single time. So instead, we'll have to do the more work, and the more work is to expand all this stuff out. So I showed all this stuff in the other two videos, and we do get to a place where once all the things cancel out, we're having the limit as h approaches 0 of h cubed plus h squared minus h all over h. So again, if I were to plug in h for 0, 0 for h, I get 0 plus 0 plus 0 all over 0, so 0 over 0. So more work to do. And that's where we're looking at that numerator and saying, okay, well, there's a common factor of h here. So let me factor out an h from the numerator, leaving an h squared and h, and this would become minus 1 all over h. And I am contractually obligated to continue to write limit as h goes to 0. These h's will cancel. Yay! And now if I plug in 0 again, I'm going to get 0 squared plus 0 minus 1, which is just negative 1. So apparently, the slope of the tangent line, the slope of the line that's tangent to this function, when a equals 1, that slope will be negative 1. And then the tangent line itself will be y equals the slope x minus the known x, and the y value was, I think, negative 3. We did that earlier, so that was the y value. Da-ding! And if I really want to be awesome and feel good about the work that I'm doing, I'm going to graph this function. I'm going to graph this line, and I'm going to see that it's going to just skim right across the graph, right there. So, you know, just try and pull some things together and explain why this algebra looks the way it looks. I'll mention one last thing. If you're hanging out for this long, you don't have to necessarily factor the h out and cancel it. There are some teachers who teach it kind of like, if you notice that everything has an h, then you can just cancel one h off of everything. It's essentially what we're doing without factoring stuff off. We're just basically saying like, okay, let me just take an h off of everything, so you're going to go away, you'll become a squared, you'll become just a plain old 1, and if I take an h away from you, you become negative 1. It's just faster than doing that step. All right, good luck, kiddos.